everyone. Today we're going to talk about regular polygons. So a polygon is a two-dimensional figure that's made of all straight lines, but a regular polygon is special. It's what we usually think about when we're thinking about polygons. It's the polygons that have all sides that are congruent and all angles congruent. So a regular polygon is also a 2D shape made out of all straight lines, but it is has all those same congruent sides and all those same congruent angles. So some examples that we already have talked about are an equilateral triangle would be a example, or a square. Both of those are polygons that have all congruent sides and angles. So today we're going to talk about finding the area of a regular polygon. And so I'm going to start out by dividing up our polygon, and I'm going to use a hexagon for our example, but the concept, I hope you'll be able to see how it applies to any regular polygon. So I'm going to divide it up into triangles. And one thing to notice is that all of these triangles are going to be isosceles triangles, because we can picture if this polygon was inscribed in a circle like this, then each of these sides would be the same length because they'd be a radius, right? So all of those sides are the same length, and they're what we call the radius. Okay. Now, when we think about finding the area, if I could just find the area of one of these triangles, then I could find the area of the whole polygon because all of these triangles have to be congruent. All of our angles are the same because a regular polygon has all congruent angles. All of those two sides are the same, so we have triangle congruence. So I now want to shift into how can I find the area of one triangle? Well, what we know is that the area of a triangle is is base times height over 2. That's the area of a triangle, right? So let's think about what our base is. Our base is the length of one side of our polygon. And so this is one of our sides, right? So that's our base. Okay, and then our height is going to be this altitude that we've dropped here, right? That's going to make a nice right angle here. So our height is the altitude. When we're talking about polygons, we actually have a special name for that height. So we call that height the apothem. So that height is called the apothem. So we have the area of the triangle would be base times height over 2, but that's not the area of the polygon. The area of the polygon, we would have to account for all the triangles. So we would take the base times height over 2, and we'd have to multiply it by the fact that there are 6 isosceles triangles. Now you have to ask yourself, are there always going to be 6 isosceles triangles, or is this just because we have 6 sides? And the answer is it's going to have the number of triangles that it has is going to be the same as the number of sides it has. So I could actually change this to be n for how many sides are there. Okay? Now, we're going to go ahead and try to adjust this and generalize this a little more using the vocabulary we know. And if I'm considering the number of sides we have times the length of that side, I'm going to draw that in for a second. The number of sides we have times the length. So the number of sides we have is 1, 2, 3, 4, 5, 6 times the length of that side, that's actually going to give us the perimeter. So I can actually think about that as P. So our area of a polygon is not just how many sides you have times the length, it's perimeter. And again, the reason why we have to multiply by the number of sides is because we don't just have one triangle. This part right here just represents one triangle, but we have multiple triangles depending on how many sides we have. And then the height is the height of the triangle, but it's not really the height of the polygon, so that's why we have a different name for it, and we call it the apothem. So, and we use an A to represent that. And so that's the area of our polygon. It comes from thinking about one triangle, base times height over 2, and then multiplying by how many there are. And then you have found the entire area of your regular polygon. Notice this is only the area of a regular polygon. I should probably have put that. Okay, so let's get out some of this vocabulary for a second. So the side is a segment, and we know that all the sides are going to be congruent. Okay, so this is our side right here. The apothem, we already wrote, is going to be the altitude of the isosceles triangle. It's what we think of as the height of the triangle. And then the radius is from the center to the vertex. Okay, so the radius is from the center to the vertex, and the reason we call it a radius is because we're picturing that circle that is circumscribed about the polygon. That would be the radius of that circle. Okay, so there are all of these types of polygons. You know, I think, a lot of these names, but as a good refresher, the polygon name comes from how many sides there are. So when we have 3 sides, it's a triangle. What is it when we have 4 sides? What's the name of that polygon? You know this one. It's a quadrilateral. Okay. Number 5, if we have 5 sides of the polygon, we have a pentagon. 6 sides is hexagon. 7 is heptagon. 8 sides is octagon. 9 sides is nonagon. 10 is decagon. And 12 is dodecagon. Those are the traditional names that we know. But let's say we want to name a 100-sided polygon. We might not know the name of that polygon off the top of our head, so sometimes we call it an n-gon because it has n number of sides. So, excuse me, let's do an example here. So we want to find the area of the regular octagon, and it tells us that it is regular, and octagon means that it has 8 sides. And it tells us we have a side length of 5. And it also tells us that we have an apothem. Remember that the apothem is the altitude of your triangle. And the apothem has 5.2, a length of 5.2 centimeters. So when I think about the formula, area equals perimeter times apothem over 2, can I find my perimeter? What is my perimeter here? It would be 5 times how many sides there are, which is 8. So I get a perimeter of 40. And what is my apothem? Well, they gave us the length of my apothem as 5.2. And so we just substituted that right in. And that gives us that the area of our regular polygon is 104 centimeters squared. Now, the fact is, we might not always know all of that information. In that example, we were given both the apothem and the side length, and that might not always be the case. Sometimes we're going to only be given one. So we're going to need to figure out how we can work with that. So in this example, it says that the area of a regular pentagon, which means 5 sides, whose side length is 10. So I'm going to go ahead and label that here. My side length is 10. Round to the nearest tenth, it says. Okay, so I'm thinking about my apothem, and I always like to draw in my apothem with my isosceles triangle. So here's my altitude, which is the apothem. And I'm noticing that in the formula, area equals perimeter times apothem over 2, I can find the perimeter, but I can't really find the apothem right now. I just don't have enough information. So here's something that you are going to be able to think about on a lot of problems like this. If I think about this dividing our pentagon into all of the isosceles triangles, one thing we know is that all of these central angles are going to be the same. And if I think about all of these central angles connected, they make a circle, which is 360 degrees. So if I divide my 360 degrees evenly into the 5 triangles that I have, I'm going to get an angle of 72 degrees. So each of these is 72. And I'm actually going to go ahead and divide 72 by 2 for this triangle that I'm trying to use here. I'm going to make it 36 and 36. Because now what I have is a right triangle. And I would like to know the apothem. I could call that x if I'd like. That's what I would like to know. And I can find that. I know this is 5 and this is 5 if the whole length is 10. So now I know one side, I know one angle, and I have another side I'd like to find. What kind of trig or special right triangle am I going to use to solve for this triangle? Well, I can use trig. I can't use 30, 60, 90 or 45, 45, 90. But I know that opposite of 36 degrees is 5 and adjacent is x. So that would be tangent. So tangent of 36 degrees would be 5 over x. And so I can go ahead and solve for my apothem. And I'm going to type this into my calculator and get a decimal approximation. But remember, I don't want to round yet. I want to leave at least 3 decimals to preserve my accuracy until the end. So now I go back to my area formula, and I need to know the perimeter, what is the perimeter? It would be 10 times how many sides there are, which there are 5 sides. So the perimeter is 50, times the length of the apothem, which is what we just found, divided by 2. And that gives me 172.0 centimeters squared. Okay, so let's look at another example. In this example, we have a hexagon. And in that hexagon, we know the radius. So I'd like you to think about which one of these, Q, S, or T, would be my radius. Well, the radius connects the center to the vertex. So it would be Q. So this is our radius, 10. Now, just like the last problem, I really need to know the apothem, and I really need to know the side, which means I could find, the leg of the triangle. Those are the things I really need, but right now I only have one known piece of information. So what should I do next to help us find something in the triangle that will allow us to find the missing sides. I'm going to go ahead and think about our angles, just like before, right? Each of these angles should be the same, and they should make 360 degrees. So if I divide 360 by 6, I get that each angle is 60 degrees, which means that each of these two angles is half of that. Each of these is both 30 to make the 60. So now, am I going to use right triangle trig or a special right triangle? I'm going to go ahead and use special right triangles, 30, 60, 90. 1 root 3, 2. X is across from the 60. Y is across from the 30. 10 is across from the 90. And so I can set up two equations. 1 over y equals 2 over 10. And that gives me that y is 5. Okay, so this is 5, which means that the whole side is 10. And I can set up the equation root 3 over x equals 2 over 10. And I get 2x equals 10 root 3. Divide by 2. And I get x equals 5 root 3. So this is 5 root 3. Now I know the side length. I know the apothem. So I'm going to calculate my area. So my perimeter is going to be 10 times 6, because there are 6 sides. So perimeter is 10 times 6, so that's 60. The apothem is 5 root 3. And I'm going to divide by 2. Note how we are finding the exact area, which means I don't just want to type this into my calculator. I want to figure out what is 60 times 5 divided by 2. And that's 150. So the whole thing is 150 root 3 centimeters squared. I don't want to give my answer as a decimal because that would be incorrect. All right, let's take a look at an equilateral triangle. So is an equilateral triangle a regular polygon? Why? Well, it has 3 congruent sides and it's a polygon, right? So it is a regular polygon. It's inscribed in a circle. The radius measures 4 root 3. So I want you to think about where that would be drawn in. I'm going to draw my isosceles triangles here. So there's my isosceles triangles. I'm going to drop an altitude. And the radius being 4 root 3 means that this distance is 4 root 3. So how should I go about finding this? What do I need to do next? Well, I can find the angles again. I have 360 degrees, right? This whole circle would be 360 degrees. So divided into 3 triangles. So 120 degrees for each of these angles, which makes, if I divide that into half, that makes 60 and 60. Now, I need to know, again, my apothem, and I need to be able to find my side length. So think about the strategy I'm going to use here. I want to use some more 30, 60, 90. Opposite from 30 is x. Opposite from 60 is y. Opposite from 90 is 4 root 3. But I forgot a key part here. I need to put in the ratios we know. 1 root 3 and 2. So I can set up 2 equations here. I can do 1 over x equals 2 over 4 root 3. And I can also do root 3 over y equals 2 over 4 root 3. So that gives me x equals 2 root 3. So that is here, 2 root 3. And then when I do y, I end up getting this. 3 times 4 root 3 equals 2y. Notice when you multiply root 3 by root 3, that's just 3. So we get this. So our y value is 6. Now, if the y value is 6, the side length is 12. So I'd like you to finish this problem. Think about substituting into our formula, and what do you get? And then just enter your answer into the system as something, and then the word root, and then something. So put your answers here. What do we get? So if we do that, we get perimeter would be 12 times 3 sides, so that's 36. The apothem is 2 root 3. And if I simplify, I get 36 root 3. You don't want to forget your units. Meters squared.